Hello students, welcome to NMIT course, Numerical Methods and Integral Transform course. I am Praveen Kumar. Today we are going to be discuss about fitting of an exponential curve. So in the previous lectures we discussed about fitting of a straight line, fitting of a second degree curve or fitting of a parabola. So today we are going to be discuss about how to construct or how to fit an exponential curve. So basically the exponential curve. So exponential curve is of the form. So we are going to be discussing this lecture is of the form exponential curve in the form of y is equal to a e power bx. How we are going to be construct the curve for the provided data, some x values and some y values provided data. So first we need to be eliminate this exponential, need to be converted into linear form. So after converting into the linear form, so we can able to easily evaluate using of straight line form. So to eliminating this, so there is exponential. So therefore to eliminating this exponential, just I am multiplying log with base e. So we know the property of log e is 1. So to make that elimination, to make that exponential 1, I am going to be apply the exponential on both sides, ln form and both sides. So apply, so you can also call it as log with base e or ln on both sides. So if you apply log with base e, or you can also call it as ln. So simply I am writing as ln on both sides. So ln y equal to ln of a e power bx. So right side is ln. So we know that ln log of ab. So we know the formula is log ab is log a plus log b expansion. So using of the same ln a, so log a is bx. So log e form we are going to be get. So where log e is already set, which value is 1. So finally we are going to be get, after simplifying this, ln y is equal to ln a plus bx. So this I am trying to be representing in the form of straight line. So for that, just I am representing in another letters. I just am considering capital Y is equal to capital A plus bx, where in the place of capital Y is equal to ln y. So in the place of capital A is nothing but ln a. So ln a we consider as capital A. So small b, capital B same, no change. But I am just trying to be representing all the letters in the capital. So capital X, small x is same. So this is what we just transforming or considering to represent this. So after representing this we know already in the curve fitting first lecture we discussed about fitting of a straight line. So which represents a straight line. So which represents a straight line. So if it represents a straight line, using of method of least squares, we are going to be considering the same normal equations. So the normal equations of this particular curve is summation capital Y. Just I am writing all capital letters. The small letter is nothing but the given data. We always represent with a small x, small y. So capital X, capital Y we considered from this equation. So where capital Y is equal to na plus b capital B summation capital X. Where the second equation summation xy a summation x plus b summation x square. So all I am writing the capital letters. If you simplify or solve these equations, we are going to be get capital A and capital B. So we are getting the capital A and capital B, but where our equation or curve we are going to be have the small a and small b. So we need to be find small a and small b by using of these particular transformations. So small b, capital B same. So therefore no change in the b. Capital B, small b same. No need to be change anything. But where if you see capital A is ln A. Capital A is ln A. But I require small a. So small a is equal to this ln I am taking to other side. So therefore simply we can write it as anti-logarithm of a. So anti-logarithm is nothing but that base. What is the base here? It is base e. So simply we can apply exponential of e power a, that capital A. So that value is called small a. Like this we need to be find small a and small b. We are going to be substitute the original given equation. That is what we can say that fitting of a exponential curve. Now we'll take one question. How we are going to be construct this exponential curve, we'll see now. So look at the question. Fit or find the curve of best fit of the type. So the exponential curve is provided. Y is equal to a e power bx to the following data by the method of least squares. So as I said just previous slide, so this we are applying ln on both sides. So just I will be write simply main steps. So ln y is equal to ln a plus bx, where this we represent with a capital Y. This is capital A, this is capital B, x. So normal equations are using of method of least squares. We are going to be get the normal equations. So same like the previous slide. I'm repeating the same. Summation y n a plus b summation x. Now, so where b quotient is x, summation x y a summation x plus b summation x square. So we need to be solve this. We are going to be get capital A and capital B. But where? So this capital Y is ln y. So capital X is small x is same. Capital X small x is same. Capital B small b same. Capital A is equal to ln A. So using of this we need to be find where small x small y is a given data, where capital X capital Y e we are going to be find using of these conversions. So where small a is required, as I discussed in the previous slide, exponential e power a. So accordingly based on these requirements, now I am going to be construct the table. So we need to be find that summations required. Accordingly we are going to be construct the table. Look at the table. So as previous slide I said, small x capital X is same. That is what I am taking the first column. Small x capital X is same. So small y is a given data, where capital Y. So from this conversation, so from this transform, capital Y is equal to ln y. That's what I am taking one more other column. Where in the equations we have summation x square. That is what I am taking another column, summation x square. Where in the second equation we require summation xy. That is what I have taken xy respect to summation. Look at that. So this is what the given data, where 1, 5, 7, 9, 12. So sum of these values we are going to be considered as capital X, which is equal to 34. So small y. So I don't have any small y in the equations where I require capital Y. But capital Y small y is not same. So capital Y is equal to ln of y. So we need to be find out the capital Y using of this. So capital Y is equal to ln of these values. So which means ln of 10. So just use a scientific calculator. You can type in the calculator. There will be usually the calculator will have two forms, log ln, where log is base 10. Simply it will be notating as log, where ln is log with base e, natural logarithm will be notated as ln. So ln of the first 10 value, it is type in the calculator, will be get 2.3026. Same way ln of the second value, ln of 15, 2.7080. Just try to be take 4 or 5 decimal places will be enough. So similar way ln of 12, 2.4849. so ln of 15, so will be same, so just you can write the same value, 2.7080. ln of 21, so 3.0445. so sum of these values required, because in the equation we require summation capital Y, so that is what we are finding these values. So sum of these values, so therefore this value is 13.248. now, so the second equation will have summation x square required, where x square we need to be find. As you know, square of these values, 1 square 1, 5 square 25, 7 square 49, 9 square 81, 12 square 144. So sum of these particular values, just type in the calculator, will we get the value is summation x square, which is equal to 300. So same way summation xy is required. So in the second equation, this also we need to be find. So first we need to be find xy. So capital X, capital Y, 1 into 2.3026. So 5 into this, 13.54. 7 into 2.4849. 17.343943. 9 into this, so 24.372. 12 into 3.0445, which will be 36.534. So sum of these values we can call it as summation xy. That summation xy value is 94.1429. So these all values we are going to be substitute in the equations. So as the equation we know it, this equation we are going to be substitute summation y. So summation y I am substituting 13.248, which is equal to ENA, number of observations, 1, 2, 3, 4, 5. So therefore it is 5A plus. So B summation x, where summation x is 34. So 34B, it is equation number 1. Similar way, equation number 2, summation xy. So summation xy we know it, but we are going to be substitute here, 94.1429, which is equal to A summation x, where summation x is here. So therefore 34A plus B summation x square. Summation x square value is 300. So 300B. So same way previously what way we solved these equations using of the calculator, just you can solve this. So therefore we are going to be get capital A and capital B. So capital A value is 2.2484. So if you solve these equations, we are going to get capital A value is 2.2484. So capital B value is 0.059. But this is not our original values. But where in the equation we have small a and small b, now we are getting capital A and capital B. So from these conversations or transforms, we need to be find small a and small b. We know that capital B, small b is same, but where small a, if you want to be find using of this transformation, we need to be find. So look at. So now since capital A, so capital A is equal to what is here? ln of small a. So ln of small a. Capital B, small b is same. But where what is the capital A value? 2.2484. So capital B value 0.059. Since capital B, small b is same, no need to be find anything. So 0.059. So one parameter is done. Now the first one, where small a is required, as we know, small a required, this if you take into our side, this we are saying that it is anti-logarithm of a, where anti-logarithm is a is equal to e power a, where e power, so the capital A value is 2.2484. Just type in the calculator, we are going to be get small a, so that small a value is 9.4725, where small a value is this and capital small a value is this and small b value is this. This we are going to be substitute in our curve. So what is our curve? Exponential curve. Y is equal to a e power bx, where a value is 9.472 to e power b. B is 0.059 into x. So this is what? So constructing of an exponential curve. Now if you want to be find any y value at x is equal to something 0.1. So just you can substitute 0.1 in the place of x. So you will be get it directly at any x value by substituting any y value by substituting x value easily. So this is what fitting of an exponential curve. So using of method of least square. So in this session we discussed about fitting of an exponential curve. In the next class we will be discuss about fitting of a power curve. Thank you.